In the endless void, further than any of us can imagine, a tiny craft is flying, launched even before many of us were born. That's Voyager 1, our most distant messenger. And for 5 long months, it was silent. Not entirely, it was sending a signal, but it was nonsense, a jumble of zeros and ones. It seemed we had forever lost contact with our pioneer. But a few weeks ago, a miracle happened. Voyager spoke again. And what it told us changes our understanding of the universe beyond the solar system. Don't forget to subscribe. This story is a true techno-thriller, unfolding at a distance of 24 billion kilometers from Earth. Just think about it. Light from the sun reaches this spacecraft in 22.5 hours. When you send a command, you have to wait for a reply for almost 2 days. Under such conditions, NASA engineers faced a computer breakdown that is older than most of them. The problem arose in November 2023. One of the 3 onboard computers, the so-called Flight Data System, or FDS, stopped functioning properly. This computer is the brain of the spacecraft. It collects data from scientific instruments and information about the state of Voyager itself, packages it all into a neat bundle, and transmits it to Earth. And suddenly, this brain forgot how to speak. The problem lay with a memory chip. Just one single chip out of the entire array had failed. Seems like a small thing, right? But on a device that has been flying for 47 years, it's a catastrophe. You have no way to replace anything. You don't even have the option to simply reboot the system, like we do with our smartphones. All you have is a radio signal and brilliant engineers who remember how to work with 70s-era technology. It's like trying to fix an antique clock with laser tweezers, while on a different continent and looking at it through binoculars. For months, engineers sent commands, attempting to diagnose the problem, probing the computer's memory bit by bit, and they found it, that very damaged section. The solution they came up with is a masterpiece of pure engineering artistry. They couldn't fix the chip, but they could bypass it. The software code stored in the damaged cell was vital, but it was too large to fit entirely into any other free memory section. So the team decided to cut this code into pieces and distribute it across various free nooks and crannies of the FDS memory. This was painstaking work. They didn't just need to transfer the code fragments, they also had to ensure that all of them would reference each other correctly so that the program would function as a cohesive whole. And all of this was done in a programming language that only a handful of people know today. On May 17th, they sent the final command and held their breath for almost 2 days. And then, on May 19th, data poured in. Clean, coherent, scientific data from all 4 instruments that are still working. Voyager 1 was back in action. It was a victory of human perseverance and intellect. 5 months of fighting for a faint signal from the void culminated in success. But the most interesting thing isn't how it was fixed, but what it managed to record during its silence and what it continues to transmit now. It is sending us a symphony of interstellar space. So what did it tell us? To understand that, you have to realize exactly where it is. In 2012, Voyager 1 officially exited the heliosphere. The heliosphere is a giant bubble created by the solar wind, a stream of charged particles from our sun. This bubble protects the entire solar system from harsh interstellar radiation. We live inside this cocoon. And Voyager ventured out into open space, into the galactic ocean. It is the only functioning spacecraft in human history that directly measures the parameters of this environment. And its data is astonishing. First, it hears the hum of space, of course not in the usual sense we understand, because there's no sound in a vacuum. What we're talking about are plasma waves. Interstellar space isn't an absolute void. It's filled with rarefied plasma, an ionized gas made up of protons and electrons. When shock waves from our sun or other stars pass through this plasma, it begins to vibrate, to oscillate. Voyager's instruments detect these oscillations. If we convert their frequency into the audio range, we get a low, constant hum. This is the voice of the interstellar medium. And thanks to the latest data, we've realized that this hum isn't so monotonous after all. It changes, experiencing its own bursts and lulls. Voyager discovered that the density of this plasma is much higher and more variable than our models predicted. Space beyond our home turned out to be more turbulent and alive. This discovery holds immense significance. Essentially, our solar system isn't merely flying through empty space. It's sailing through a heterogeneous medium, full of plasma clouds of varying densities. It's like sailing a boat across the ocean and suddenly encountering patches of warm water, then cold currents, then areas of increased salinity. Voyager is our thermometer and hydrometer in this cosmic voyage. It helps us map out our immediate galactic neighborhood. These are fundamental insights into what neighborhood of the galaxy we call home. Secondly, Voyager is our only shield positioned against galactic cosmic rays. This isn't just background radiation. These are high-energy particles, mainly protons and atomic nuclei, accelerated to near-light speeds by supernova explosions and other catastrophic events in the galaxy. Inside the heliosphere, the Sun's magnetic field deflects about 75% of these particles. We are safely protected. But Voyager takes the full brunt. Its detectors constantly count these particles, measuring their energy and direction. And the latest data confirms their flux is much more intense than we thought. This means that our heliosphere is an even more effective protector than we had anticipated. Without it, life on Earth would most likely be impossible. Essentially, Voyager allows us to see what the world would be like without the protection of our Sun. This data is invaluable for planning future interstellar missions. When humanity eventually decides to send a crewed vessel to another star, Voyager's data will form the very foundation of radiation shielding calculations for both the ship and its crew. This tiny probe, created 50 years ago, is working for our distant future. Quick fact: the energy of a single galactic cosmic ray particle can be comparable to the energy of a ball thrown by a professional baseball player. The thing is, all that energy is concentrated in a subatomic object. But the Voyager story isn't just about science, it's a story about us. Attached to its side is a golden record. It's a message in a bottle cast into the cosmic ocean. On it are recorded the sounds of Earth, the sound of rain, birdsong, a child's laughter, and the music of Bach and Chuck Berry. It contains greetings in 55 languages from around the world and 116 images of our planet and our civilization. This record is our portrait, launched into eternity. The odds of it ever being found are infinitesimally small. But that's not what truly matters. What truly matters is that we did it. We, beings from a small planet, decided to tell the universe about ourselves. And this tale is continued by the probe itself. Launched in 1977, it was only intended to operate for 5 years, exploring Jupiter and Saturn. But the mission proved so successful that it was extended. It flew past Uranus, past Neptune, and journeyed on towards the boundary of the solar system. Its twin, Voyager 2, incidentally, also left the heliosphere, but in a different direction, and is now also sending us invaluable data. These spacecraft are absolute record holders for longevity and distance. They are a triumph of engineering ingenuity and insatiable human curiosity. However, their time is running out. The Voyagers get their power from radioisotope thermoelectric generators, which run on the decay of plutonium-238. And this plutonium is slowly but surely depleting. Every year, the power drops by approximately 4 watts. For many years now, engineers on Earth have been fighting a real battle for every watt, by switching off secondary systems and instrument heaters to extend the life of the most crucial scientific instruments. According to current projections, by approximately 2025 or 2026, there won't be enough power to operate even a single instrument. And after 2030, the craft will most likely fall silent forever. This is precisely why Voyager 1 coming back online is so vital. These are its twilight years, its swan song. Every measurement, every single bit of data it transmits is priceless. This is data we won't be able to obtain again for decades, not until we launch a new interstellar mission. We are listening to the final words of the most intrepid traveler in human history. It's telling us about a world we may one day venture into. A world full of invisible magnetic fields, streams of charged particles, and echoes of ancient stellar cataclysms. Someday, it will fall silent. Its transmitter will cool down, and it will turn into a silent piece of metal, hurtling through the galactic night. But its journey won't end there. It will continue to fly for millions, billions more years. It will pass other stars. Perhaps it will outlive humanity itself and planet Earth. And aboard it will be a golden record with the voices, music, and images of a long-vanished civilization. So next time you look up at the night sky, remember it. Out there, in the unimaginable distance, in the direction of the constellation Ophiuchus, a tiny craft is flying. It is an extension of our eyes and ears. It is the embodiment of our yearning to look beyond the horizon. And now, after 5 months of anxious silence, it speaks to us again. And we must listen very carefully, for it is a voice from the great void, telling us about our place in the universe.